Hi guys, my name is Kamagelo, widely known as King K, and many other people call me Harry. Today we're going to focus on problems related to the center of mass, which refers to a point that moves as thought all the system mass were concentrated there and all external forces were applied there. There are two methods that we can use to find the center of mass of a system of a particle. If you are given a right angle triangle like this and you are required to find its center of mass, you are basically looking to find the point where all these three lines meet, which is this point, and its coordinates, which is the x center of mass and the y center of mass, will give us the center of mass of this given system, which is a right angle triangle. There are two methods so we can be able to find the center of mass of a system using the masses of an object and also the area of an object. Using the masses, the x center of mass is given by 1 over the total mass of the system multiplied by the sum of the masses multiplied by the x coordinate of the particle. And then to find the y center, of mass, the y center of mass is given by 1 over m multiplied by the sum of masses at that point multiplied by the y coordinate at that point. And this starts from I is equals to 0 all the way to a certain value of n. Even this starts at I is equals to 0, 1. I is equals to 1, not a 0, all the way to a certain value of n. So these are the main equations we're going to use to find the x coordinate of the center of mass and the y coordinate of the center of mass using the masses of each and every particle in the system. And then there's also the area method, whereby now you are not given the masses. So using the area method, the x center of mass is given by 1 over the total area multiplied by the sum of the area of that shape multiplied by its x coordinate of the center of mass. And the y center of mass is given by 1 over the total area. It's given by 1 and the y center of mass is given by 1 over the total area multiplied by sum of the sum of the area of that shape multiplied by each y coordinate of the center of mass. When you use the area method, it is important for one to familiarize themselves with these formulas or for how to find areas of different shapes which can be a rectangle, a triangle, a circle, semicircle, a quarter circle, and also an ellipse. So these are the basic equations that the basic shapes that we have to know how to determine their areas and their coordinates for both x and y center of mass. As we can see for rectangle example, its x center of mass is half of the breadth and its y center of mass is half of the edge, half of the height. So familiarize yourself with these equations as they will be helpful in solving as many questions that we may come across in under this subtopic center of mass. And as a tip, it is important for you as a student to be able to visualize your problem by drawing a diagram, as this can help simplify the calculations. Now we're gonna look into this problem. It says 3 particles of masses 4.763 kg, 3.389 kg, and 12.223 kg form an equilateral triangle of edge length 153. Now let's visualize the problem. We are given that these 3 particles of masses they form an equilateral triangle, and we all know that an equilateral triangle is a triangle with equal sides. They form an equilateral triangle. So this is our equilateral triangle, and then each edge length is 153 centimeters. If 4.763 kg mass is at the origin, we are also given that. Let me draw the Cartesian plane. This is our Cartesian plane. This is the x-axis and this is the y-axis. So we are given that the 4.763 kg mass is at the origin. Now let's label. This is our origin. So here we have the mass of 4. We have the mass of 4.763 kg. And then we are also given that the 3.389 kg mass is along the x-axis. That means it's going to be positioned here. This is 3.389 kg. And then we are also given that the 12.223 kg mass is in the positive x and positive y quadrant. So this is the positive x and the positive y quadrant. Thus, our other particle will be located here, which has the mass of 12.223 kg. So this is the information that is given. And then now we have, they say the center of mass of the whole system will be Earth. So we have to find the X center of mass and the Y center of mass. So here we're going to use the mass method. So in order for us to find that center of mass, it's going to be, so in most cases, I prefer to use a table, as it is easier to write all the unknowns and ensuring that nothing is left out. So I'm gonna make use of a table. So since now I have all the required information, I can continue and do my calculations. So what do we have? We have a table. Let me not do it this way. Let me just draw a line like this. And then I would say here, these are our particles. Let me also draw another line like this. So this column, we're gonna have our particles. We have the particle A, we also have the B, and we also have the C. Perfect. And then we know the masses of each and every particle. So let's label the masses. So these are the masses in kg. So we have for A, on my diagram, before I forget, we can label this mass here on the triangle as A. We can label this to be A, and then this to be B, and then this to be C. Right, so the mass at A, which you can say, call it a particle A, it's 4.763, and then at B it's 3.389, and then the last one, which is the C, is 12.223 kg. Then here we have 12.223 kg. So that will be our first column, our second column, the masses, and then let's now move on to the third column, and then the third column will be the X center of mass. So the X center of mass, let's go back to the diagram. So when we look into the diagram, and then we have to determine the X center of mass at particle A, we can notice that the particle A with a mass of 4.763 kg is located exactly at the origin. Therefore, the X coordinate of the center of mass will just be 0. And then at point B, we can see that at point B, it moved a certain distance from, it is located a certain distance from the origin. And since this forms an equilateral triangle, this base of the triangle will as well be 153 centimeters. 153 centimeters will as well be 153 centimeters. And then it didn't move any distance on the Y. So we can now notice and see that the X center of mass for point B, which is the coordinate at the particle B, it's the distance. It's how much? 153 centimeters. And then for point C, we can notice that it is located on the axis of symmetry. Since this is it's an equilateral triangle, a triangle with equal sides. So we can notice that the X coordinates, it's basically at the middle. Therefore, this tells us that the X center of mass at this particle C will be 153 divided by 2. And then 153 divided by 2, that is going to give you 76.5. Let me use a different color. Here it's not that clear. 76.5. 76.5. That is the X center of mass. Now we move on and determine the Y center of mass. I'll just do it below here because I don't have a space. So I'll just make a line like this, and I will call this the Y center of mass. The Y center of mass, for particle A, it's located at the origin. It didn't move any distance on the Y and the X axis. Hence, its Y coordinate of the center of mass will just be 0. So this is for A. So it is just a 0. And then this, I'll call it a B. And then for B, B as well didn't move any distance up or down. Therefore, it's exactly at the origin. It only moved along the x-axis. Therefore, its y coordinate of the center of mass will just be a 0. And then now the last one, which is the C, then C. Then to find the y center of mass for C, we can notice that we have a right angle triangle here. Therefore, we can use the Pythagoras theorem, since we know the hypotenuse to be 153 centimeters and the base to be 76.5, to find what this height, right? Because that is the distance at point C along the y it's located at. Therefore, by Pythagoras theorem, what are we gonna have? We're gonna have that the y coordinate, that will be the y coordinate of the center of mass for C, will be given by the square root of the hypotenuse, which is 153. Let me start this again. We're gonna have the y coordinate of the center of mass for C will be the square root of 150, the hypotenuse 153 centimeter squared, 153 centimeter squared, and then plus the base, which is 76.5 squared. Then the y coordinate of the center of mass of C is going to be, let's punch this on a calculator, 153 squared plus 76.5 squared. I made a mistake. This was supposed to be a minus. Apologies. This was supposed to be a minus. Let me rectify that. This is minus 76.5. Minus 76.5. Since this is the y and this is the x, right? X squared plus y squared is equals to r squared. In this case, our r squared is the 53. Our y squared is the 53. So now we're gonna have the y coordinate of the center of mass for C to be equals to the square root of the hypotenuse squared minus the x coordinate, which is the base 76.5 squared. And this is going to give us, when we punch on a calculator, it's going to give us 132. This is going to give us 132.50. I'll just say 2. And this is the y coordinate of the center of mass at the particle C. So let me write it here. This is 102.502. Therefore, now we have everything that we need. Now I can just erase this and remove this. So we have everything that we need. We have both the x coordinates of the center of masses and the y coordinates, and as well as the masses. We can go ahead and find the center of mass, the x coordinates of the center of mass for the whole system, and as well as the y coordinate. So the x coordinate of the center of mass of the whole system, so will basically be equals to, remember by the equation, as I've explained previously, the x center of mass is given by 1 over m by the sum of the masses at each and every particle multiplied by the x coordinate of the center they multiplied by their x coordinates. So the x center of mass here will then be equals to the mass at A multiplied by the x coordinate at A plus the mass at B multiplied by the x coordinate at B, and then plus the mass at C multiplied by the x coordinate at C, and this will be divided by the total mass. And then all these values are given. We have the mass of A, and then we have the x coordinate at A. We have the mass at A, which is 4.763 and its x coordinate, and we have the mass at B, which is 3.389 and its x coordinate, which is 153, and then we have the mass at C and its x coordinate, which is 76.5. So when you substitute all these values on your calculator, you're gonna get that the center of mass is, so this will be, let me punch it, 3.389 and then multiplied by 153 plus, and then the last one is 12.223 and then multiplied by 76.5 divided by the total mass, which is going to be 4.763 plus 3.389 plus 12.223. Then this gives me and then this gives me 71. This gives me 71.341. That is the x center of mass. Then we do the same with the y center of mass. The y center of mass, it's going to be equals to the mass of A multiplied by the y coordinate of A plus, not really the y coordinate of A, I meant to say the distance where A is located from the origin, and then plus mass at B multiplied by the y coordinate at B, and then plus the mass at C multiplied by the y coordinate at C, and then divided by the total mass. So even this one, we have everything on our table. The mass is 4.763 for A and its y coordinate 0. And then for B, its y coordinate is 0. The mass is 3.387, C is 12.223, and its y coordinate is 132. So since the y coordinates for both A and B are just 0, so that is just 0. So we're going to have 0 plus 132. 0 plus the mass of C, which is 12.223, multiplied by its y coordinate 5.0, 132.502 divided by the total mass, which is given by 4.763 plus 3.389, and then plus 12.223. Then this is going to give you 78. This is going to give you the y center of mass to be equals to 79.488. And that is the center of mass of the whole system. Hence, the center of mass for the whole system Hence, the center of mass for the whole system will be equals to 71.341, and then and 79.488. That is the solution for this problem. Thank you.